Arithmetic recurrence relationships for modeling simple interest. Simple interest is a way of looking at investment or borrowing when you earn or owe, depending on whether you are investing or borrowing, a percentage of the principal invested in every time period. Sorry, I'll start writing more neatly. I don't know what happened there. You'll remember from possibly year 10, simple interest. Say I've got $100 invested, that is the principal, and I'm earning 10% simple interest. 10% of $100 is $10. I would just get an extra $10 every year. That's it. It's really boring. So obviously, since I'm adding $10 every year, this is an arithmetic recurrence relationship. So when we're modeling simple interest, we tend to use Vn rather than Tn for value. So V0 is our principal amount borrowed or invested. V for value. So obviously Vn is the value after n time periods, usually years. N is the number of time periods. Now, normally in our interest calculations, we're looking for R, the rate, the interest rate that we're getting. But actually what we're going to use is capital D, and that is the amount of interest paid every time period. And we calculate D by doing the interest rate, R, over 100 times the principal. That is effectively, all we're doing is R% of the principal. Because if our interest rate, R, is like 3%, 3 divided by 100 times the principal finds 3% of the principal. So the recurrence relation form, our standard recurrence relation would be T1 is A, Tn plus 1 is Tn plus D. That's our standard recurrence relationship form. For simple interest, we use V0 is the principal, because we're not, you think about it, V1 would be the value after one time period. So V0 is the starting amount before any interest has gone in. And then Vn plus 1 is Vn plus capital D, because D is the amount of interest that we paid, and we work it out like this. It's the same as the common difference, really. So it looks exactly the same, we're just changing it up for simple interest. So using those to answer some questions, Cheryl invests $5,000, sorry about shuffling around here, in an investment account that pays 4.8% simple interest per annum, that's per year. I can't write today. Model the investment using a recurrence relationship. So V0 equals the principal. Now let's have a look at what we've got. I've got $5,000 principal, and this 4.8 is my interest rate, R. So I will need to calculate D. D is the rate over 100 times the principal. That would be 4.8 over 100 times the principal of 5,000. Please do show your working for D. You've got a formula for it. You might as well show it. 4.8 divided by 100 times 5,000. So this gains us $240 every year. Sorry, that's a D there. And then we just use our rule. V0 is the principal. Vn plus 1 is Vn plus D. So write the general form of the rule, then write the form for this problem. It's like a formula and your actual substituted values. Principal is 5,000, Vn plus 1 is Vn plus 240. That's it. That is our recurrence relationship. Use that model to find the value of the investment after 3 years. We can just work recursively. We start with 5,000 and hit enter to get it over to here. And I want to add 240 plus 240. Now that's 1 year, 2, 3, 4. Oh, I wanted 3 years. So 5, 7, 20. If you've worked that through on the calculator, that's fine. To show proper working, if you had the time in the test, start with 5,000. So V1 is 5,000 plus 240, 5,240. V2 is 5,240 plus 240, which is 5,480. So if you've got time in the test, it's a really good idea just to show the working. 5,480 plus 240, oh, we've got them here. 5,720. Now, we want after 3 years, so this is after 1, after 2, and after 3, so that's our value. There we go. So I've got my extra little 5,000 sitting there. So yeah, show working if you can. When will the investment first exceed 6,000? So click through until we get to 6,000, which was here at 3, 4, 5 years, after 5 years.